Additive manufacturing, empowered by generative design, is revolutionizing how production parts are being conceived and produced. A digital thread that connects, integrates, and intuitively captures design, materials, and manufacturing parameters is key for the production of functional parts. Additive manufacturing applications on the 3D Experience platform enable and accelerate the digital transformation by providing a single unified environment for designers, manufacturing specialists, and simulation analysts to collaborate on for generative design, build planning, virtual printing, and post-processing. With function-driven generative design applications, you can create parts that are optimized for specific applications. Start by creating a general design space. Add loading parameters and materials to the model using the step-by-step guide. Generate and validate optimized shapes for the specified constraints. Create trade-off studies to select the best design for the chosen manufacturing method. Finally, generate detailed geometry and perform functional validation on the final design. The additive manufacturing fabrication applications allow you to design and plan out any additive process. For your machine of choice, you can create a build volume and build plate, automatically nest parts to maximize build volume usage and minimize supports, set custom rules for slicing, scan patterns, and process parameters for the entire build or for individual parts. Finally, visualize the scan path for diagnostic checks. The additive manufacturing process simulation applications allow you to create detailed simulations of the printing process. Simulating the printing process allows you to predict the behavior of parts during the manufacturing process. By understanding the thermal distortions and residual stresses, you can reduce time and material costs from the actual print process and even predict build failures, such as recoder collisions. Using a guided workflow, you can configure the user interface to reflect your chosen manufacturing method, such as direct energy deposition, selective laser sintering, or polymer extrusion. Further, with access to manufacturing support definitions and their design parameters, such as spacing, thickness, envelopes, and anchors, support variants can be quickly configured and studied to determine the optimal amount of support necessary to ensure build success. All of the acquired knowledge can be captured in rules that help guide the support structure strategy. After the build simulation is complete, subsequent simulations can be used to look at build plate removal, heat treatment, and other post-processing effects. Here, the reverse shape optimizer application is used to digitally morph the original part design to compensate for thermal distortions during the manufacturing process. With this compensated geometry, the as-manufactured part is equivalent to the as-designed part. 3D Experience enables you to define and plan additive manufacturing processes to achieve predictable and reliable part builds using a flexible framework for process simulation, allowing you to accelerate your development rate, optimize your production time, and minimize cost by fully harnessing a virtual end-to-end additive manufacturing workflow. Innovate with confidence using 3D Experience.